Good day everyone. Today we are going to discuss about set. Set is a finite or infinite collection of objects in which order has no significance. Sets in day-to-day life simply means collecting a group of objects which we want or do not want. Example, a collection of songs in your playlist, collection of Marvel movies. Members of a set are often referred to as elements. In our example, vowels in the English alphabet, let V is the set of A, E, I, O, U. E is an element of V, while D is not an element of D, since D is not in the set of vowels in the English alphabet. In the second example, first 7 prime numbers, let X be the set of 2, 3, 5, 7, 11, 13, and 17. We can say that 3 is an element of X, while 4 is not an element of X since 4 is not a prime number. In the set of even integers, we have 2 is an element of E since 2 is an even number, and 3 is not an element of E since 3 is not an even number. Now let's discuss the different ways on how to describe sets. One way of describing set is by listing, or what we call the roster method. The set can be defined by listing all its elements, separated by commas, and enclosed within braces. Example, even integers between 50 and 63. We can write this as A is the set of 50, 52, 54, 56, 58, 60, and 62. Another way of describing set is by set builder notation. The set can be defined where possible by describing the elements. For example, we have this example. This is written as C is the set of all X such that X is an integer greater than -3. Now let's talk about the different types of sets. Different types of sets are classified according to the number of elements they have. First is empty set. Empty set is a set containing no objects. It is written as a pair of curly braces with nothing inside or using the symbol phi. Example, let A be the set of all X such that X is a natural numbers between 9 and 10. Now this set is an empty set since there is no natural number between 9 and 10. Why? What are natural numbers? Natural numbers are whole numbers starting from 1. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. Now, we cannot see any natural number between 9 and 10 since the number between 9 and 10 are either irrational or rational numbers. Next, we have the singleton set. Singleton set is also known as a unit set. It is a set with exactly one element. So these are examples of singleton set, a set with only one element. Next is the finite set. Finite sets are the sets having finite or countable number of members. Example, P is the set of 0, 3, 6, 9 up to 99. So these members of P are countable. We can count it from the start up to the end. Another example is Z is the set of all A such that A is an integer greater than 1 but less than 10. What are these numbers? These are 2, 3, 4, 5, 6, 7, 8, and 9. And we can count them. Another type of set is infinite set. An infinite set is a set whose elements cannot be counted. An infinite set is one that has no last element. Example, the set of whole numbers. Another one is the set of integers. Next, we have the equal sets. Equal sets have the same elements. Again, they have the same elements. Example, we have these three sets A, B, and C. We can say that A is equal to B since they have exactly the same elements. In A, the elements are 1, 2, and 3. In B, the elements are 2, 1, and 3. So regardless of the order or of the position As long as they have exactly the same elements, they are what we call equal sets. Now, A and C are not equal sets. Why? Although they have the same number of elements, but in the definition of equal sets are sets with exactly the same elements. If we're going to look at the set A and the set C, they have exactly the same number, but not the same elements. In A, the elements are 1, 2, and 3. In C, the elements are 4, 5, and 6. Now, let's talk about the equivalent sets. Two sets are equivalent if the number of elements of both sets is the same. Example, we have these sets. Now, we can say that A is equivalent to C. Okay, in A, the elements are 1, 2, and 3. The set C, the elements are 4, 5, and 6. They don't have the same elements, but they have the same number of elements. When we talk about the same number of elements, you are talking about equivalent sets. But when we talk about exactly the same element or elements, we are talking about equal sets. So here we can say that A and C are equivalent set. And set A and set B are not equivalent set. Why? Set A has 3 elements and set B has 4 elements. Next, we have the universal set. Universal set is a set which contains all the elements or objects of other sets. This is denoted by U. Now here we can say that U is the universal set of set A and set B, since all the elements of A and B are in the universal set. Next, we have the subset. A is a subset of B when every member of A is a subset of B. In this example, we can say that A is a subset of B, since all elements of A are in B. We can also say that A is a subset of A, or A is a subset of itself. Why? Because all elements of A is in A. Same with B is a subset of itself. Next, we have the proper subset. The proper subset of a set is a subset of A that is not equivalent or equal to A. Again, a proper subset of a set A is a subset of A that is not equal to A. So proper subset is also a subset. The only restriction is it must not be equal to itself. Example, we have this set B and set A. We can say that A is a proper subset of B, since all the elements of A are in B. But we cannot say that B is a proper subset of B, since according to the definition of a proper subset, it must not be equal to itself. Same with A is not a proper subset of A. Thank you.